Hello everyone. In this video, we are going to discuss how to write a program to calculate the sequence components of line currents when the unbalanced phase currents are given. In this case, we are discussing for a three-phase system, for a three-wire system. Okay. In the next video, we are going to discuss the same calculation for four-wire system. Let us dive into the concept. And the aim of this experiment is to determine the sequence component of a line current in three-wire system. Let us take an example. And here we are having, and this concept, the currents that we have chosen is a three-phase unbalanced system where we are having IR, IY and IB, the known parameters of the current, and the unknown parameters that we need to calculate is the zero, positive and negative sequence components of the currents. Let us choose the first phase, that's the R phase, where here we can see the IR naught is the zero sequence R phase current, which is calculated as 1 by 3 times the sum of the unbalanced currents, that's IR, IY and IB. Similarly, the positive sequence of the R phase current is IR1, which is calculated as 1 by 3 times IR plus A times IY plus A square times IB, where the component A is a constant value and we have already shown in the previous videos. Please click on the link so that people can get to know more about it and the value of A also. And the negative sequence R phase current IR2 is calculated as 1 by 3 times IR plus A square IY plus A times IB. Okay. Similarly, the Y phase and B phase currents are calculated as shown here for Y phase, and this is for B phase. If you want to write a program for this calculation part, let us open the MATLAB. Yeah, this is for the sequence component of voltages when the unbalanced voltages are given. Now let us start with a new programming window where we are going to start our programming part. CLC is to clear the command window, and then clear all is used to remove the items from the workspace and to free up some memory. Then we need to start getting the known parameters, right? And here we have the known parameters as IR, IY and IB. So let us start with IR, which is equal to, using input command we can fetch the data. IR is the unbalanced R phase current, and IY is unbalanced Y phase current. IB input unbalanced B phase current. Okay, see here we have not, because that's not necessary, but still we can use. Oh, here it is, TB. It's IB. Now we know we have fetched the input parameters. Now we need to calculate the sequence components of R phase, Y phase and B phase. Let us start with R phase. We are using command line for R phase sequence. Components. R phase sequence components are IR naught. IR naught is zero sequence R phase current. IR naught is equal to, as we have already mentioned, 1 by 3 times IR plus IY plus IB. Similarly, IR1, it's also 1 by 3 times IR plus A times IY plus A square times IB. Since here we are having a multiplication part, we can use one more phrases just to make sure the calculation part will be accurate. Similarly, IR2 for negative sequence, that is 1 by 3 times IR plus A square times IY plus A times IB. Right? Yes. Just to cross verify, this is our IR naught, IR1 and IR2. 1 by 3 times IR IY plus IB. That's what we have written. 1 by 3 times IR IY and IB. And IR1, 1 by 3 times IR plus A times IY plus A square times IB. IR A times IY and A square times IB. Similarly, IR2, 1 by 3 times IR A square IY A times IB. IR A square IY and A times IB. Now we need to calculate for Y phase and B phase. Now for Y phase it is IY naught is equal to IR naught. Starting for Y phase sequence component, that's what we are calculating. IY naught is equal to IR naught, right? And IY1 is equal to, what was the equation again? IY1 is equal to IR1. No, it's not. IY1 is equal to and I have just made some mistake. IY1 is equal to A square times IR1 and IY2 is equal to A times IR2. Now using these two equations we can write the program again. IY1 is equal to A square times IR1. A square times IR1 and IY2 is equal to A times IR2, right? A times IR2. Similarly, we can calculate for B phase. B phase again, IB naught is equal to IR naught. Moving on to the B phase percentage. These are the command lines that we are typing here, which are not being executed. Now, IB naught is equal to IR naught. IB1 is equal to, IB1 is equal to, what was the equation? IB1 is equal to A times IR1. A times IR1 and IB2 is equal to A square times IR2. A square times IR2. Okay. Now we got the program. Since we haven't used columns here, we are going to get the output executed and will be printed, and no need to worry. Now we need the values for unbalanced currents. So we need to consider. Oh, sorry, here we have not closed the bracket, so it is being shown. Alright. Now for that part, to get to know the input parameters, let us consider a problem where three-phase unbalanced system, the value of IR, IY and IB are given. Okay, and to complete the program, we need to know the value of A also along with IR, IY and IB. So in the previous program, we have already taken the value of A. Let us just paste it here since it is a constant component. And if you run this program, it is asking to save. Let us keep it as I1. Let us save it. Enter path. Now it is asking for unbalanced R phase current, and from the problem we can take IR is equal to 12 plus J6. 12 plus J6. Sorry, can't put it as small letter J6. Okay. 12 plus 6J, is it right here? 12 plus 6J, we need to enter the J later. And now Y phase is 12 minus J12. 12 minus J12. And the B phase, the value is minus 15 plus J10. Minus 15 plus J10. Here we can see elaborate R phase current, IR0, IR1 and IR2. Now whether the calculation is right or no, so here we have solved the program. Let's move down, and if you check it out here, IR0 is 3 plus J1.33. Here it is 3 plus J1.33, and IR1 is, here is IR1 value 10.85, 10.13. 10.85, 10.13, right, on 2, 7. And they have rounded it off. IR2 value, and here we are having IR2 value minus 1.85 minus 5.47 minus 1.85 minus 5.46, which is very much near values. Similarly, IY0, IY1 and IY2. For yellow phase, IY0 is equal to IR0, which is same. IY1 is equal to 3.35 minus J14.4. Here we are having 3.35 minus 14.4. IY2 is 5.6, 1.12, 5.7 and 1.13. The decimal values that they have rounded it off to a single digit. That's why they have taken it to the next value. Similarly, IB0 is same as that of IR0 and IY0. IB1 minus 14.19 plus 4.33. Here we are having IB1 minus 14.2, 4.31. 14.19 is 14.2, they have rounded it off. 4.33, they have rounded it off to 4.3. Similarly, IB2 is minus 3.8 plus 4.3. Minus 3.8 is 4.3. Now, the calculation parts are exactly matching. with our theoretical calculation. Now, if you want to print the value to the exact decimal values, please go back to the first program that we have done on MATLAB, where we are going to use fprintf command to adjust the values to the nearest decimal values whichever we need it. So, hope you people enjoyed the video and learned something. If you people have any doubts, please do comment below. We'll be connected. Thank you.